For this video, what I would like to do is to go over, we've talked about rationalizing that denominator and how to get rid of the radical out of the denominator if it is there. But we've only focused on if it is a square root, if we're talking about just a perfect square root. So I wanted to work a couple problems of how we go about doing that if we have something that is raised to the third power. So let's just take a look at, let's go ahead and take a look at a problem right now. If we have 6 over the cube root of x. So if we're trying to take the cube root, that means we have to have something raised to the third power inside in order to get rid of to pull it out of the root. So just like if we were doing the square root, we're going to have to multiply this number by 1, so something over something. And in this case, we have a single x in here. So in order to get an x cubed, we need to have 2 more x's. So we'll do the cube root of x squared on the top and on the bottom. So now when I've multiplied this out, I have 6, the cube root of x squared divided by the cube root of x times x squared. When we add together our exponents, or even if we break this apart further, we have 6, the cube root of x squared over the cube root of x times x times x, which means we have 3 x's. And in this case, so this would be x to the third, we're going to divide up x to the 3, we're going to divide it by 3, which gives us 1. So our final answer will be 6, the cube root of x squared divided by a single x. Okay, we can apply that again if we have a case where we have another example problem. Let's just say that we have 7 over the fourth root of 2. So again, we need to have 3 more 2's in here in order to be able to take the fourth root of 2. So what we're going to do is take the fourth root of 2 cubed divided by the fourth root of 2 cubed. Again, the same thing over itself is always going to be 1. So when we multiply this out, we have 7, the fourth root of 2 cubed divided by 2 times 2 cubed gives us 2 to the fourth. The fourth root of that will just give us a simple 2. So that is going to be our final answer. So we can go through the same process whether or not we have a perfect square or whether or not we have it more complicated depending. Okay, so always remember that we want to make sure we get rid of the root in the denominator. So the next part that we want to go over is going to be our section 10.1. In 10.1, we're looking at how we can solve these equations by using our quadratic equations by using the square root property. So the easiest thing to start out with is that when we have the form of x squared is equal to our value k, it's simply that we can take the square root of both sides. So for example, if I have x squared is equal to 36, in the previous section, you all saw that you could subtract 36 from both sides, and you would come up with x squared minus 36 is equal to 0. Then you could factor this to be x plus 6, x minus 6 is equal to 0, and then you'd solve each one setting it equal to 0, so x was equal to positive 6 or a negative 6. Well, instead of having to do all of those steps, we can simply say x squared is equal to 36, and I can take the square root of both sides, pull out my x, and this is going to equal plus or minus 6, because remember we have the plus or minus when we take the square root. So that's going to be the easiest way to go about solving these quadratic equations when we have the case of a perfect square. So another example is if we have, let's say 4r squared, 4r squared is equal to 26. We want to get the number all on one side and the r on by itself. So we're going to divide both sides by 4. So r squared. And now I have 26 over 4. I'm going to go ahead and take the square root of both sides. And the reason for that is because while I could reduce this fraction, it would leave me with a root on the bottom. So I'm just going to leave it as is, take the square root of both sides. I get r is equal to the square root of 26 over the square root of 4. So I can go about seeing if I can reduce this any further, which I can. If I was factoring, if I divide 26 by 2, it gives me 13. So there isn't any way to reduce this or to simplify this radical. So I'll have the root of 26 over the square root of 4 is 2. So my final answer is going to be r, the square root of 26 over 2. Not to forget the plus or minus, because it can either be positive or negative. So if we have a little bit more complicated of an equation where we have something like this, where we have p minus 11 squared is equal to 49, I can do the same thing. I can take the square root of both sides, which is going to pull out my p minus 11 is equal to the square root of 49 is going to be a plus or minus 7. So then I can solve for p. So I can say p minus 11 is equal to either a positive 7 or p minus 11 is equal to a negative 7. Then I will solve for p, add 11 to both sides. So in this case, p is equal to 18, or p is going to equal, add 11 to both sides, and that will give me a positive 4. So p is equal to either a 18 or 4. And we can always check our work for that. If everything isn't neatly on one side, so if I have an example of a problem such as where I have 5x plus 4 squared minus 2 is equal to 16. I want to get this 2 out because we have a perfect square here. So if I add 2 to both sides, that's going to give me a 5x plus 4 squared is equal to 18. I'm going to take the square root of both sides. So I get 5x plus 4 is equal to plus or minus the square root of 18. And I can simplify that down further, right? Because I know that 18, when I factor it, is a 9 times 2. So I have 5x plus 4 is equal to plus or minus the square root of 9 will give me 3, the square root of 2. So I will subtract my 4 from both sides because now I want to get my x by itself. So when I subtract, I have 5x is equal to a negative 4 plus or minus 3, the square root of 2. I'll divide both sides by 5, divide both sides by 5. I get x is equal to negative 4 plus or minus 3, the square root of 2 over 5. And that is as simplified as I'm going to be able to get this equation. Okay, so whenever you're doing that, that is how you go about making it more simplified. You always want to make sure that if you're doing this root, then you have everything on one side such that you can take that square root. So let's take another look at another problem, shall we? So if we did, let's just say we take this, let's take 3d squared plus 14 is equal to 41. So the first thing I want to do is I want to get this d squared by itself. So I'm going to subtract both sides by 14. So I get 3d squared on this side is equal to From the 3, 11, so that's going to give me 7. 3 minus 1 gives me 2. Divide both sides by 3. Working to get that d squared by itself. 27 divided by 3 is 9. I can now take the square root of both sides. D is going to equal plus or minus 3. So it could be a positive 3 or a negative 3 to satisfy that equation. Let's go ahead and take one more look of another example. Let's go ahead and look at if we have, let's go ahead and look at this example real quick where we have 2b plus 9 squared plus 18 is equal to 0. So again, we need to get the square by itself. So we're going to subtract 18 from both sides. And I'm going to write this as 2b plus 9 squared is equal to now a negative 18. This problem now becomes a no solution. And the reason why it is a no solution is because we have this negative sign here, and we're unable to take the square root of a negative sign. Therefore, there isn't going to be any solution for it. So that's how you go about working out these problems. If you have any questions, be sure to email me or come on office hours. I'd be more than happy to work more problems for you and help you out further. Have a great day.